Hello again, dear grade 9 students, and let's continue our chapter. And now we are going to talk about expanding factors. So as you see here, these are two factors. The first factor contains a plus b. As you see, there are letters, and the second factor contains c plus d. So how do we apply expanding factors? We just make like this: a times c plus times plus is plus a times d, then b times c plus times plus is plus b times d, and as you see here, there are no similar monomials to be added, so we keep the result like this. So this is how to expand factors. There is another way called the smiling face way. It's like this: we take a with c, b with d, then we take b with c and a with b, and here is the smiling face as you see. So you can use any one of these two methods to expand factors. Now let's take another example. To expand these two factors, I have to multiply the number by the number, so I'll start like this. 2 times 3 is 6. A times a is a squared, so I get 6a squared. Then 2a times minus b is minus 2ab. So 2 times minus 1 is minus 2, and a times b is just ab. Then 3 times 3 is 9, and the b times a is ba. So I have plus 9ba or ab. These are the same. ab or ba are the same because you know that multiplication is commutative. And finally, I have to multiply 3b by minus b, then I will get minus 3b squared. Where does 7ab come from? It's the result of minus 2ab plus 9ba, and the final expanded form for these two factors is 6a squared plus 7ab minus 3b squared. So when adding 9ba or ab with minus 2ab, then I will get 7ab in the middle. And by this, I finish expanding these two factors together. Now here are important identities that we are going to use to expand factors in order to save time. The first identity is called the square of the sum. So here is the first identity. It is called the square of the sum. Okay, it is a plus b squared, then I have to multiply a plus b by itself. So as if two factors that include a plus b are going to be multiplied together or expanded. So a times a is a squared, a times b is ab, b times a is ba is the same as ab, and b times b is b squared. Then I get ab plus ab, so I will get 2ab. So again, a times a is a squared, a times b is a b, b times a is b a, it's the same as ab, and b times b is b squared. So ab plus ba gives 2ab, and this is the result of this factor. So a plus b squared can directly give a squared plus 2ab plus b squared. It's like squaring of the first term plus 2 multiplied by the terms, these two terms together, plus squaring of the last term. So this is the first identity, that's called the square of the sum. Now here is the second identity. It's similar to that one, but in the middle, the sign is here minus. So I'm going to expand a minus b squared. It's like expanding a minus b into a minus b again. A times a is a squared. A times minus b is minus ab. Minus b times a is minus b, the same as these ones. And minus b times minus b is plus b squared. So notice that the extremities are positive, because if you multiply plus with plus, you'll get plus, and if you multiply minus with minus, you'll get plus. So always the extremities are positives. In the middle, the sign is according to the given sign in the middle. So if there is plus in the middle, then the sign in the middle is plus. If there is minus in the middle, then this sign in the middle is minus, while the extremities are always positive. The second identity is also called the square of the difference. So it's the square of the difference. Okay? And finally, here is the last one, the third identity. A minus b into a plus b. So as you notice, you have the same terms, but in the first factor there is a minus sign between them. In the second factor there is a plus sign between them. Then if I start expanding like I taught you, a times a is a squared. A times b, and there is a plus, plus a times plus b is plus a b. Minus b times a is minus b a, and minus b times plus b is minus b squared. I can cancel these opposites to get just a squared minus b squared, and this identity is called the difference of two squares. So whenever you have like this factors carrying the same terms, but in the first factor there is a minus sign between the terms, in the second there is a plus sign between the terms, or here is plus and here is minus, never mind, then all what you have to do is just squaring of the first minus squaring of the second, and by this you can save time. And we've seen this in rationalizing the denominator in the previous chapter. We just square the first one, put minus, and square the second one. And this is called the difference between or of two squares. Now, in the next slide, we are going to take examples in order to apply these identities and to be more familiar with them. So let's go to the next slide. Here is the first example. I'm going to apply the first one, 3x plus 1 squared. As I told you, 3x squared. So we have to square the first one. We have to put the same sign in the middle here, plus, so we put plus. We multiply by 2, then the first one, then the second one, and finally plus squaring of the second term. So the first term is 3x, then squaring of the first term is 9x squared, plus, as you see here, plus, because in the middle there is a plus sign, so we put a plus sign, 2, this is from the property, into the first term, multiply by the first term, multiplied by the second one, and then I will get 6x plus 1 squared, and the final result is 9x squared plus 6x plus 1, and we stop here. Here is an example on the second identity, the square of difference. 2x minus 5, all of it squared. So I have to square the first term. So it will be 4x squared, minus in the middle, then minus in the middle, 2 from the property, into the first term, multiply by the first term, which is 2x here, and the second term, which is 5. So I will get minus 2 times 2, 4 times 5, it's 20. And plus, as I told you, the extremities are always positive, so plus squaring of the second, which is 5, so plus 5 squared, which is 25. And the final answer is 4x squared minus 20x plus 25. Finally, 7x minus 3 into 7x plus 3. You notice that you have the same terms, but here there is a minus sign and here there is a plus sign. So all what you have to do is just to square the first term minus squaring of the second term. And by this you get 49x squared minus 9. I just stop here. Here is a higher level example. I have two identities in the same statement. I have to apply the second identity or the square of the difference on this one and the difference of two squares on this one. So let's start. 2x minus 5 squared, it's like this one. Squaring of the first, then it's 4x squared, minus in the middle, so I put minus in the middle. 2 from the property times 2x, then I have 4x, times 5, then I have 20x, and the plus squaring of the second term, which is plus 25. Minus 3 is kept outside. Now all what I have to do is to keep 3 outside and to expand these two factors using the last identity, which is the difference of two squares. Squaring of x is x squared minus squaring of the second one, which is minus 4. And then I'm going to introduce minus 3 into this factor. Then I will get 4x squared minus 20x plus 25 from these. I put them again. Minus 3x squared, and minus 3 times minus 4 is plus 12. And finally, I can add the similar monomials, which are 4x squared and minus 3x squared. Then I will get x squared minus 20x is kept as it is. Now adding 25 with 12, I will get 37. And here is the final answer of this one.